Okay, let's get started. My name is YuLing Chen from Cisco, together with me, Prem Shankar from Ericsson, and today we are going to present this topic of OpenDaylight-based machine learning for networks. I believe everyone went to yesterday's keynotes from Dave Myers about machine learning for networks, and here we share the same view. We believe currently most SDN products are using static control of traffic in the network, right? And we believe the next generation of SDN needs to be dynamic control of the network based on the status, the current status in the network. We believe we would need to leverage machine learning in this case. So a little bit background of ODL MILA Workgroup. It was established March this year from ONS Summit. Prem and I delivered a speech talking about this idea, and after that we kind of had about 10 people interested in this topic, and we started to work on that. Similar to, machine learning in networking is still in very early stage. So are we. We are in also very early stage too. So today we would like to present some early activities, including POC demos, for this topic. Okay, first we would like to talk about the contributors to this project. As always, people are always the most important thing for the project. We have contributors from Cisco, myself, Prem from Ericsson, and TCS. I would like to mention two very important people, Rashmi and Razi, who did a lot of POC work, for this project, and Xflow Research also actively working on this. And I would like to hand it over to Prem to talk about why we need machine learning ODL.
Okay, thanks, YuLing. The main context in which we wanted to bring in the machine learning was, for example, if you look at OpenDaylight, you have a lot of data coming in from various modules, right? So if you look at OpenDaylight, it started as a SDN controller, but today you have close to 45 plus applications. The amount of data they deal with is enormous, right? So what is that we wanted to do was we wanted to probably leverage the data that are produced by various these modules and then build or provide an API layer above OpenDaylight so that people can use it as a platform. For example, to begin with, you can have supervised learning, then you can move on to unsupervised learning. Okay, so before that, I just want to understand how many of you are familiar with the machine learning basics so that, okay, 1, 2, 3, 4. Okay, so probably I'll spend 5 minutes just to touch base on what machine learning is, and then I'll probably move on to the topic. So machine learning, as the name suggests, is basically making the machine do some autonomous decision making. So for that to make, you basically, it's similar to that of how we learn, right? So how do we learn? We basically learn based on standard set of resources, and then over the period of time, we do course correction to whatever we learned, right? After a certain stage, unconsciously, of course, we cannot compare brain to that of a typical processor, but then just to say how we behave, we tend to sort of get more and more external data, and then we become super intelligent, right? Depending upon the area you are in, right? So similarly, machine learning is an area where you're trying to make the machine analyze the data, train them with standard set of course, there are standard techniques to train them. One famous one is the artificial neural network, and there are a bunch of them depending upon the use case, right? And then what you do is you basically look at how it has learned, then provide its input, and then after a certain stage, it becomes more autonomous in nature, and which means that it can do things by itself, right? Just to give an example, if you remember around March this year, there was a famous announcement about AlphaGo game player, the machine learning system that was developed by Google, bet a Go player who was well known or who was famous, right? And then the interesting part is they did an analysis on how the player lost the game. Looks like since the AlphaGo was trained with huge data set, and also the data generation was basically what they did was they created 2 instances of AlphaGo, and then they made it fight with each other so that there was a lot of data that gets generated during those games. So there was a move that as a human, you would think it is not intelligent, right? But then that made the difference in the game, right? So that's just an example wherein how people are leveraging machine learning, right? So coming to our relevance, right? So as I was mentioning, what are the key things in our scenarios, right? One is we say that the controller needs to be intelligent, right? So which means that what happens is when you look at a typical infrastructure requirements, right? Soon most of the enterprises are moving towards more of a cloud-based, be it a private cloud or public cloud. In that case, when they go on a service model, the key important thing is the ability to look at or predict what would be the request that would come in. For example, Amazon Web Service, right? The number of requests that come in is in millions, right? Which means that it's going to grow exponentially. But how is that they are going to manage or understand their infrastructure need, or how are they going to plan it? So that's one other important scenario wherein if you look at from a relevance of machine learning, that's one other area what we can look at. So what is that we want to do is, as it mentions, so the SDN when it means is, it has to be intelligent. Today, SDN, in a way, what happens is you have an orchestrator. It's mostly machine driven, right? Wherein he knows that this is how the network has to be. And in case of fault, he basically goes and debugs the fault, fixes it, and then so on and so forth. In fact, there was an article around 2 months back where a person wrote that soon the data center would be automatic. In the sense, what is meant by automatic is you would essentially see that the human intervention, those small human interventions that are needed today is going to go away, right? So what is that is needed? So one is DevOps. Okay, so from a DevOps perspective, what it does is DevOps essentially simplifies the provisioning as well as configuration of the various components, be it compute, be it network, be it storage, right? Next is ability to foresee a possible issue coming into that of the system, right? What is meant by that? For example, let me give an example. In case of our scenario in Ericsson, right? We do have a lot of virtual network functions deployed, right? In the conventional model, what happens is a failure is detected. Post the failure, we tend to act on it, right? For example, a typical case would be some network has gone down. Typically, it's human's nature to keep trying, right? Because you are in a panic mode and you keep trying, right? So which means what happens is the number of calls that lands on it exponentially increases. The system is going down, but the service or request that's coming on it is exponentially going, right? Can it be solved, right? Yes, why not? The first step is look at the patterns that causes the failure, right? Which means that collect those data set much in early, give it to that of the machine learning, right? Which means that by that what happens is you know that from a set of patterns that you know that it's going to, a problem is on the making, right? A simple thing, for example, you use Windows, right? So when you have so many of your processor applications spawn, you see that there is a memory peaking, right? So in earlier days, it used to be the next stage would be blue screen of death, right? But now it's a different scenario. But what I'm trying to say is you do see that the system is melting down, right? Can you preempt it before and take action, right? Yes, you can do, or you can take action. So the idea is use such instances or use such data that is used for debugging system, feed it to the system, and then you are able to predict or preempt a possible failure, right? So these are some of the examples in which what we wanted to leverage. And as I was mentioning, we wanted to make ODL the brain of the network, right? So if you look at the solution, some of the solutions what we have in the market is SDN is being used for as a cloud SDN controller. What is meant by cloud SDN controller is it provides or it manages the network for a cloud provider, right? So in that case, there are a bunch of things like tenant isolation, tenant prediction, so on and so forth. You do get it. So look at the sheer number of modules you have. For example, you do have TSDR. The project basically is meant for, it stands for time series data repository. It collects data from SNMP, it collects from various sources, and it does archives and does analytics based on it. Then you have group-based policy. You have VPN service, which talks about the cloud SDN. Then you have SFC, then you have topo processing. So all of the, it's just a sample set of the applications what you have in OpenDaylight, right? Let's take GBP, right? So if you look at group-based policy, what is it about? It talks about creating a relationship between two entities, right? A simple thing, for example, if you look at a simple misconfiguration, if you're familiar with like a BGP VPN type of thing, there is a concept called, there are two parameters. Those two parameters are the parameters that differentiate between one tenant to another tenant. A small misconfiguration is basically going to screw up the whole system, or the traffic is going to be mapped to some other customer network, right? But if you can train the system can look at it and then identify whether the configuration is right or not, right? And then can preempt, right? Next is VPN service. As I was mentioning, we have a lot of data coming out of VPN service. The main essence of VPN services is to create network virtualization, which includes tenant isolation, right? So what happens in case of tenant isolation, we do create environment. For example, if you are an enterprise, if you are familiar with AWS VPC, Virtual Private Connection, we provide you a similar facility, right? Which means that there is a lot of data that gets generated by VPN service, which you can use for cloud resource planning. So I can go on and what we want. So these are some of the examples. So one is traffic control and routing optimization. For example, you can do a predictive congestion control, traffic pattern prediction, routing optimization, resource optimization, whatever I was mentioning. So network resource allocation and optimization, cloud resource management optimization. This is an interesting one, security and anomaly detection. For example, DDoS attack detection, wherein, in fact, a key thing in DDoS attack is when you're a cloud provider, you would suddenly get a request for, say, 1,000 or 2,000 VM requests, let's assume, right? If you don't train the system properly, or even if you have a simple analytic mechanism, you would essentially think it is a DDoS attack because you are being flooded with some request, right? But if you have a machine learning system, you can basically correlate sources or information from other things, and then you can take a decision and then say, no, this is basically a genuine request coming in from one of the tenant, right? And other thing is, of course, troubleshooting and self-healing. When I say self-healing, look at the existing logs. For example, you have a bunch of information being spewed out of the log files, take it as an input, and then you can basically guide in troubleshooting. So this is the essence in which we wanted to build. So probably YuLing will continue on the framework.
Right. Thank you very much, Pam. So again, this is a very simple example we actually presented last summer. On the left-hand side, you can see there's a network, whether it's virtual or physical, doesn't really matter, but you can see from A to F, there are multiple paths, right? If we have an algorithm, we can predict in the next 24 hours there will be congestion between A and F, and we can change the configuration of the network and reconfigure the policy so that we rebalance the traffic so that this congestion wouldn't happen. So that's the kind of simple example of leveraging the data we collected from network and the algorithm, machine learning algorithm on the data. So inspired by this simple example, as MILA Workgroup, at the very early stage of MILA Workgroup, we actually did some experimentation on this topic. What we did was, relying on ODL TSDR, we collected the interface metric, SNMP interface metric, and then feed to Weka, which I believe quite a lot of people probably know about this tool. We feed to Weka, it's a Java-based machine learning tool, and used 4 different types of algorithms and generated the result for the prediction in the next 24 hours. And we can see actually in this diagram, the Gaussian and SM or EG kind of a little better in this way. But does that mean the goal of MILA work group is looking at the algorithm, optimize the algorithm? The answer is no. Then we talk about what are the goals of ODL MILA work group. We believe the goals of this work group are two perspectives. One is to adapt SDN architecture to machine learning requirements. Specifically, we would like to provide an application framework for machine learning ODL in SDN. And then we would like to look at how do we add necessary components for intelligence or knowledge plane. In research area, there have been already some paper published talking about what constructs, components needs to be added into SDN in order to support machine learning, and one of them is knowledge plane. Because everyone knows that we have data plane and control plane, application plane, and some talking about management plane. But in order to satisfy the requirements for machine learning, really achieve the intelligence for the network, already research paper talking about we need a knowledge plane and intelligence plane there. So we would like, as a work group, we would like to experiment to see what are the actual components we need to add in this intelligence plane. And also we would like to integrate with ODL native network data collection as well as traffic control services to make it a holistic end-to-end solution for machine learning. Second perspective is we would like to facilitate machine learning application development in ODL. What does that mean is, we actually looked at the user group of ODL. We understand there are two types of people. One, they are very savvy in machine learning algorithms. They are professors, they know about the machine learning algorithm, they would like to experiment, optimize the algorithm itself, right? That's one type of people. The other type of people, and most of the users of ODL, they are network professionals. They are not machine learning experts, right? In order to satisfy the need and also to facilitate application development from those major groups, we believe we would like to, first we want to integrate with third-party machine learning algorithms, libraries, to make it natively available from ODL. And secondly, we would like to provide abstract and generic northbound interfaces for machine learning applications. For example, if the application developer would like to say, I would like to predict the traffic congestion, bandwidth utilization for port 1 or for the link 1, right, between port 1 and port B, port 1 and port 2, and say, what's the congestion, what's the bandwidth utilization in the next 24 hours? What the interface will look like would be just predicts as the operation and port 1 or port 2, and then also the matrix bandwidth utilization and the 24 hours. Those should be just the necessary interface and parameters for the user. And the user can just make the call, and how internally the machine learning algorithm is picked, is selected, and how do you do the machine learning, the user doesn't need to care about it. So that's the idea of facilitating machine learning application development in SDN in ODL. That's one of the goals of MILA Workgroup. And high level in general, we believe that's how it's going to work. At the bottom, you can see that's the network, right? And we have time series data collection, continuously collect the data from the network. And then we feed it to the advanced analytics and machine learning, this construct. And that's going to be the ODL, we believe that's the ODL AI ML framework. And then after analyzing and applying the machine learning algorithms, it's going to generate the result and then feed back to other services that Prem just mentioned, different types of services that can configure the network, can replace the policies to make changes and steer the traffic on the fly. So that's in general what we believe going to look like. Sure.
So one other thing I want to add here is you cannot have a template type of thing, or you cannot have just one rule apply for all, right? So the type of machine learning algorithms that you apply differs from use case to use case, right? So typically, if you look at how a machine learning or how a learning happens is, you first identify the data that you want to feed it to the system, right? And you basically label that these are the data sets that I want to take it and then input it to the system. So even when you input it, there is a bit of transformation that has to be done, right? So which means the key for any machine learning system is the data that you collect and also the data you want to feed it to the system for analysis. That is step number one. Step number two is analysis of the algorithms that you want to apply for your problem domain, right? For example, you have like umpteen number of machine learning algorithms that are, for example, K-clustering, even within ANN, if you take artificial neural networks, it basically creates similar to that of our brain, right? So there are summarization points, and these summarization points has various methods that you apply, and you get the results in a different way, right? So post-analysis, you also have the next stage is what you want to do. What is the decision you want to do, whether you want to act on it or you want to observe it, which means there is a bit of feedback that comes into the system, and it further builds or improves the ability to predict things in a proper way, right? Then you basically get into the action, right? So as YuLing was saying, our intent was to create a framework for it, which means that, for example, if you have an algorithm, you can bring it, you can tap onto the data points, have it designed, and then check it into sort of like a library wherein you can say that and tag it, wherein you can just a second. So wherein you can always say that, hey, this particular problem domain, this is the type of algorithms I will use. That is one. Second thing is, again, data can be historic data and real-time data. So when I say historic data, most of the most of the infrastructure was based on historic data, which means that your data would be probably a week old or 2 weeks old, right? The other model is streaming data, wherein you, for example, there are infrastructure like Spark ML lib. Spark is basically a real-time based, I would say, like a Hadoop type of thing, wherein it basically processes the stream data and then it does it. It also has a machine learning plugin. If you plug it in, you can process the real-time data. So we were planning to have both offline data or historic data as well as the real-time data. So that's our intent of this whole framework.
So can we skip to the very end, because we are running out of time. Sorry about that.
Yeah,
because we still have a demo to show. I'm going to talk about the constructs a little bit and very quickly. Time series data repository, good news is it's already the third release now. Starting from Lithium, we have started to develop it. And I'm not going to talk about the details. The architecture are posted online. So from historical, like Prem said, historical machine learning, offline machine learning point of view, it's pretty much ready, the data, right? But then we are going to talk about how the MILA framework, the architecture is still high level, how that's going to look like, and what is missing, and what we are exploring right now, right? Again, ODL AI ML framework is, talking to both the time series data collection piece as well as other ODL services. One side is to gather the status of the network. And as Prem just mentioned, there are two data paths we would like to enable. One is historical, because when we look at machine learning algorithms, three types, offline, online, and reinforcement, right? And then they need two different types of data. One is historical there. For offline machine learning, typical way is they are going to look at the historical data and train the model based on the data over the time. So that's why we need the historical data to collect it in a scalable way to provide to those machine learning algorithms. But at the same time, there's online machine learning, which can, gather data on the fly all the time, continuously. And this one, we need the real-time data directly and on the fly right away from the network. And for that, we believe we need an architecture to enable that. And here, we are exploring Kafka and Spark together to provide that capability. And based on that, we have an architecture that's a POC architecture. Again, we are not designing the framework yet, but instead we are exploring the technology to see how do we integrate together with ODL. Okay, and then particularly I'm going to show a very short demo in a minute. What we did was, using an Open vSwitch, Mininet simulated Open vSwitch. It's going through the OpenFlow stats data collector. TSDL provides that. So it collects the data On one hand, it feeds to ODL TSDR data repository, has historical data. And on the northbound, we have RESTful APIs. And then there's the offline machine learning module that's going to query the data from ODL TSDR through the RESTful APIs. And after it gets the data, it applies, in our case, Spark ML lib. We're using that library, using k-mean clustering, a very simple algorithm, apply on the, it's specifically the flow size metric we collected from OpenVSwitch, and then we categorize into different clusters and show it visually. So that's one POC we've done, which I'm going to show in a minute. And the second one is still, we collect the data from the Mininet OpenVSwitch, but we push to Kafka bus. And at the same time, the offline machine learning, the online machine learning module is going to consume the data directly from the Kafka bus, and then again call Spark ML lib, k-mean clustering library, that algorithm, and construct RDD, the resilient distributed data set, and send to Spark streaming. And Spark streaming can process data based on the algorithm in parallel, in memory, and eventually send out the result as clusters, the categories of flow size, and visualize it. I'm going to show the first one now. So this is a recorded demo. The first one you can see is the Carafe console. And here we install ODL TSDR HSQLDB all. And with that, we install both the HSQLDB data store as well as the OpenFlow stats collector. So after we install that, it will start to collect the data from OpenVSwitch. And at the same time, our TSDR list will show, okay, the data already collected, okay, in row format. And then the Mininet here, what we show is already we have a Mininet simulated OpenVSwitch pushing data to ODL collected by TSDR. So that's one thing. This is the very simple application we created for offline learning, and it uses curl commands to query the data from TSDR and then apply Spark ML lib k-mean clustering on the data and visualize it. So this shows the flow size categories into 3 clusters. The lower one is the small size, the middle one is medium size, and upper top one is the large size. So you can see the activity on different time. So each chart shows every 5 minutes how this flow looks like. So it starts from, this is the first one, and second one, and third one, and the fourth one. You can see this is a starting point because lots of dots, 0, very small, and it started picking up in the middle, and then eventually stabilized as this, so which means most of the time it stays in the medium size here, stable. So that's the simple example POC we did, try to test the architecture there. So that pretty much concludes our presentation and demo, and this is the last one at information and contacts.
Yeah, and the biggest challenge what we have is data. The availability of real-time data is key to harden or to conclude on any particular machine learning algorithm or a pattern. So that's one thing. If you want to use machine learning, you need to have a data set, a real data set, so that you can train your system.
Yeah, now we take questions. Go ahead.
Yep.
Yeah, go ahead.
Could you go back to that last architecture diagram? Yeah, this one. Okay, essentially, as far as ODL is concerned, the current architecture, are you opening any new API for ODL, or you're using existing API?
Currently, this exercise using existing API.
Yeah.
This is the TSDR northbound RESTconf API,
Yeah.
right? But that's not the design or the API for ODL AI/ML framework. We are not there yet. The API I talked about as abstract and generic, that's something else. Yeah.
But you have indeed the batch processing and the real-time streaming data, yeah?
Right, these are 2 different paths.
So one
The
is a
left-hand
real-time
side is
path and another one is a batch processing path.
The tools that are today, the tools that are available Are you,
Hadoop is actually a batch processing.
yeah.
So
Are you bringing that as part of the historical data or not?
We're using HBase as one of the ODL TSDR
TSDR.
repository. HBase is built on top of Hadoop. Yeah, yeah.
And the fine-grained data is real time.
Yes,
So that could be like the
yes,
Right,
that's
that's
streaming
what
data.
streaming data.
Yeah, yeah.
you had a question.
One of the things about it in the end is the separation of data plane and control.
Yes.
And in terms of the knowledge plane, I would actually argue what you do here is probably, in my opinion, more correct. You also separate the knowledge plane from the control plane.
Right.
To build anything into ODL, actually combines the two where it's not necessary to do. But once you do that, the control plane, the data plane, once you push the data sources into the knowledge plane, it's a separate entity, that is a separate process.
Right.
That's not only taking data from the other two planes, but also taking visual information.
Yes.
The Super Bowl's coming next Sunday, so expect more traffic.
Right.
You know, and so what are you actually planning to change in ODL
Okay.
versus keep the separation of the plane?
Well, the Super Bowl is a very interesting point. I mean, that's always a challenge because whatever you monitor, you analyze, you model, right? It's on normal basis. Whenever that exceptional case happens, it's really hard for any algorithm to capture. So that's why in my earlier diagram, I have a user input or external data
External
that
data.
should add on top of whatever the data from the network, right? So,
So
that's a separate
yeah.
topic.
So that's the main intent of keeping the user path is essentially to get external data sources so that your correlation is perfect. For example, another simple thing is you can also tap into Ceilometer to get like whether there's a VM creation, there's a massive VM creation and feed it onto it so that you can correlate your network traffic pattern to that of it so that you don't melt down when there is a sudden request of VMs coming in.
Right.
So
I guess the real point is I'm hoping to keep the plane separate.
yes,
And
yes.
you don't try to put a bunch of stuff in ODL.
Absolutely. And yes, and one other point to add is we also spoke with a SmartNIC vendor wherein they were basically having their own like a data collector type of thing. What they do is they collect the data, they don't just punt it up because the volume is so high. They do a bit of cleaning up or analysis and then they feed it to the top layer. For example, in case of this is a SDN controller or ODL. So these are different patterns wherein the amount of data that gets generated is huge, and then you need to do a bit of cleaning at the source point so that you get the relevant data. That's one other thing.
So, almost the same question. Like, half that moving here is the learning process, right?
Yes.
Which is where we generate the model. What do you have in mind? How do you go to deploy those models? Where are you going to deploy them? How many thoughts?
Yeah, we did, like Prem mentioned earlier, and we also presented that in webinars. We are thinking about having a repository, algorithm repository, so that we can allow the registration of different algorithms. So,
So that would be user-based, right? Because this essentially becomes an application, right? Right. So wherein, for example, you can essentially look at the existing repository and then just instead of building your own thing, if something satisfies, you can just pull it and then plug it into the system. So there are different models that we are evaluating, and then the idea is, in fact, we were looking at TensorFlow also to be a plug-in to the system.
yeah.
So that TensorFlow does have all the facilities for this, so that you can leverage on TensorFlow infrastructure.
Yeah, yeah. Different libraries we're looking
Different
at.
libraries.
Spark ML is one of them, and Deep Learning 4J is another, and
Another
TensorFlow is a third one. And eventually we want to, integrate with as many as libraries as possible to provide the algorithms as many as possible to the northbound, so that application can use and develop their applications.
So what is the first use case you want to cover that you feel will have an impact and will tell the story?
I still believe the prediction of the congestion would be very important. Yeah.
Yeah, that is
Yeah.
one, and we were also thinking of DDoS attacks.
Yeah. There's also collaboration that we are doing with, universities looking at the optimization of the routing on overlay using machine learning. Yeah.
Data, like you said, right? 80% of the time, if you're doing data analysis, you spend cleaning up data, right? That's what it is. Nothing sexy. Right? Are you thinking of gathering data, synthesizing data?
could be down the road. I mean, especially from the TSDR, we have some modules in the future to see if we can do some pre-processing of the data, cleansing of the data, can kind of expose the plugins for the user to say, okay, for particular use case, what kind of logic you want to insert for cleaning up the data, for pre-processing the data. It's possible, yeah.
I understand, but that's one source of data. We're talking about
Yes, so another thing is we believe with that data repository, so that was the idea for TSDR, because now we already collect the data from NetFlow, SFlow, from OpenFlow, right, from syslog. The idea is really have all different data sources putting together, and we created a common data model. So just like different people talking different languages, right? It's hard for you to generate intelligence, but if we make them into one data model, it's very easy for correlation to happen. Yeah, so that's the same idea. If we have user data, external data, if we can massage them into common data model, we can do correlation based on that, yeah. Mm-hmm.
That's one thing that Spark was actually useful too. You can actually take all your data sources, massage them in streaming, and
right.
push to the database, which is a little weird when I saw TSDR originally added in OpenDaylight. It wasn't going from something like Kafka to Spark, where it would just be an endpoint in Spark to push it down to TSD. Are there plans to change that architecture and how the data gets down there? Spark streaming?
Are you talking about the streaming part?
Yeah, why not have an
Definitely.
end of the streaming back to TSDR as a massage data, first run that one.
Well, whether we feed back to TSDR, that's another question, because we can talk about that, because this part, the second pass, we should build it for the streaming, because it's missing right now.
It just goes back to TSDR again.
Yeah, it could be possible up to you.
It doesn't have to be an ODL process.
Right.
Yeah, it's pretty much outside.
Yeah, definitely, yeah. After you process it, but generate something and push back, yeah.
So there was one other, sorry. Yeah.
I think you mentioned the research paper. Do you have a reference?
Yeah, I can send you reference. Yeah, yeah, definitely. Yeah, no problem. Mm-hmm.
I had a question about the term before, maybe that's a little bit detailed. So, first of all, thank you, and also for the demonstration of showing how the workflow is. So, not that it's really important, but I don't see why we would do clustering on time series. I mean, I understand that you are just going to demonstrate how the workflow works.
Yep.
I'll help you.
Okay, sure. Thank you. Any other questions? Oh.
The parallel projects? Panda project. No, Panda, it's a good thing.
That's another question. We can talk offline.
Yeah.
There has been some consideration exactly talking about, integrate with Panda.
Panda.
Yep.
One thing I can work, if you look at all this data, especially measured or even the open source standard or whatever other level we need to take from our machine learning perspective. Sometimes we are other people.
Right.
Yeah, we can definitely feed to Panda. Yeah, that was the consideration, and it might happen. Yeah.
Any other data type connected.
Sorry, you mean any?
So any other, like,
type?
for example, any data source from which you can tap in. For example, instead of we collecting the data, can we look at other data sources they collect and then?
Yeah, definitely. TSDR already opened the northbound, say, add matrix, which means whatever data collector you have, you can call the northbound API from TSDR to feed into TSDR. And then that becomes one more addition kind of data source, right, in the same repository. Yeah, we've already opened that API. Yep. Any other questions? Yeah.
Sorry, is the ODL MILA, is that an existing project or is it proposed from?
TSDR is already there for the third release. This one is not a proposed project yet. It's a work group. We're working on POC prototypes right now.
Based on TSDR, it's an extension to TSDR.
Yeah, it's an extension to TSDR at this moment. And also as open source projects, open source work groups, we welcome everyone to join us, so that we can grow.
And also bring data.
Yeah, bring data too. Yeah, that's another thing. We like to have the original data to help us with the projects. Yeah.
Is there a repository where people could start contributing data?
Yes.
Yes.
Not the data, the source code is there, probably data you can.
We have
share,
source.
Yeah, we can.
Yeah, we can talk. We can create one if needed.
Yeah, right.
Mm-hmm. Yeah.
It's all about data.
Yep, definitely. All right, thanks everyone for
Thank
coming.
you.
Thank
Thanks.
you.